Hey, honors physics students, how about a few hints for the text assignment on chapter 2 and 3? Probably you already noted that the textbook assignment is only on chapter 3. There are some problems on chapter 2 that are pretty good, but we're going to ignore them for right now. So the chapter 3 assignment, remember these hints. I'm not going to give you hints about every problem, and the hints will get you started, and feel free to come in for more help on these. So this will be a few hints on some of the problems, and many of the problems on the Chapter 3 textbook assignment. So I'd like to start with number 79. As you look at number 79, if an object like a car goes at constant velocity, this is the time that you use the average velocity formula of just d over t. We use this formula whenever you're going at constant velocity or a steady velocity, as these cars are doing. So you might begin this process by using the displacement the car travels, velocity times time. Now each car will travel a displacement. Once you find those, then you can put them together and then find the average velocity for the entire journey is the total displacement the car travels divided by time. So that'll be a good way to start number 79, both part A and B. Let's switch to number 80. This one is asking for the uniform acceleration. On every problem in this unit, and really for the whole year, I advise writing the knowns and unknowns. If the car is changing from 32 meters per second to 96, you should write the units just as we have in our formulas, or the variables as we have in the formulas. V1 equals 32 meters per second. V2, the velocity at the end of the interval, is 96 meters per second. The time is 8.0 seconds. And write the acceleration as a question mark. This is maybe the most important idea, because then you simply have to look on our formula sheet to find the one formula with all of those four and solve the problem from there. Take a quick look now at number 82. And again, I'd advise you to click pause to work these out if that would help you a little bit. 82 has to do with the graph of velocity versus time. In each interval, we're asking for the acceleration. What you need to recognize regarding graphs is the acceleration is the slope of the velocity graph. Now, it's the slope of the graph, and it's the tangent if it's a curve. So, but instead of being a curve, you will find the graph, and see if I can put this on here for you to see. You'll find the graph looks like this. So when you do the slope, you're going to simply take the rise, which in this instant would be 30 meters per second, divided by the run, which is 5 seconds. And for each interval, you could use that technique to find the rise over run and the slope. And so all of number 82 could be helped that way. Let's take a quick look at now number 84. Now again, number 84 is asking, in this case, for the final velocity of the proton. Now there are two formulas you can use. When you write all the knowns and unknowns, you will discover that A equals V2 minus V1 over T is a very good formula. However, we solve for the final velocity so many times that one I've given you is the V2 equals acceleration times time plus V1. This is an especially useful formula here and in many problems. Skip ahead now to number 88, and let me give you a couple of hints about this one. This time the dragster is starting from rest. When they say starting from rest, it is assumed then that you will record this as a V1 equals 0. That's a huge piece of information because you can't solve the problem unless you have this as a known. Then if you write the other knowns as acceleration equals 49 meters per second squared, the displacement is 325, V2 equals question mark. Then you find the one formula that has those four would be the V2 squared equals V1 squared plus 2AD, and that should give you solution if you solve that to number 88. Let's switch now to problem number 98. Give you a couple of hints about that. The stone is dropping in this one, and it's going to free fall for 8 seconds. When something drops, the V1 equals 0. But what pulls on it, of course, is gravity. So I will say this a couple different times. So when you're just dropping it, the acceleration of gravity is 9.8 meters per second squared, a steady acceleration. That will also help you on number 100 and 101. The important thing to remember in every one of these problems is you get to decide. You choose direction. You get to choose direction. So if I ever drop something downward, if downward is the direction, the only direction it's going, then I call the acceleration of gravity 9.8 meters per second squared. But if you toss it downward, instead of starting at 0, the V1 is 2.0 meters per second in that circumstance. That should help you there. And one final hint on number 109. Okay? On number 109, it gives you 3.5 kilometers per second and 2.0 centimeters. Convert. All the time you want to have things in meters and seconds. And then the rest of it falls in place nicely. I hope you enjoy the assignment.